Good morning, or good afternoon, or good evening, everyone. My name is Andrei Belinsky, and today I'm honored to present our research entitled Capturing Bitcoin Market Dynamics, Assessing Advanced Permutation Entropy Metrics as Early Warning Indicators. This research is a collaborative effort with my esteemed colleagues Vladimir Solovyov, Andrei Matvichuk, Tatiana Kmityuk, and personally me, Andrei Belinsky. Our motivation arises from uh, recent significant advancements highlighted by Nobel Prizes awarded in fields exploring complex systems and machine learning. Notably, in 2021, Sukur Manaba, Klaus Hasselmann, and Giorgio Parisi received the Physics Nobel Prize, and in 2024, Copfield and Hinton were recognized for their foundational contributions to artificial neural networks and machine learning. These advancements underscore the importance of understanding complex systems and developing predictive tools. Inspired by these scientific breakthroughs, our research aims to analyze complexity dynamics within cryptocurrency markets, specifically focusing on Bitcoin. Using permutation entropy and its enhanced versions, we strive to identify reliable early warning indicators for cryptocurrency market crashes, providing vital insights for investors, regulators, and policymakers. Cryptocurrency markets such as Bitcoin are inherently complex and volatile, characterized by high unpredictability and nonlinearity. Traditional analytical methods often fail to accurately anticipate rapid market changes, particularly crashes. Permutation entropy, a complexity metric capturing the randomness and order in time series data, offers a promising alternative. Our research enhances classical permutation entropy by incorporating amplitude-based adjustments, such as weighted permutation entropy, amplitude-aware permutation entropy, and uniform quantization-based permutation entropy. Our goal is to improve the detection and prediction of cryptocurrency crashes by accurately capturing nuanced market dynamics. For researchers and practitioners interested in applying these methodologies, we have developed a comprehensive guide on complex systems modeling using Python, including hands-on examples and practical tools available publicly on GitHub for further exploration. Let us briefly revisit Shannon entropy. Introduced by Claude Shannon in 2048. Shannon entropy measures the uncertainty and unpredictability within a dataset or signal, providing a quantitative assessment of complexity. High entropy indicates high uncertainty and complexity, whereas low entropy suggests predictability and order. Shannon's foundational work has profoundly influenced various fields, including telecommunications, data analysis, and financial markets, laying the groundwork for advanced metrics like permutation entropy. As emphasized by Bayes in What is Entropy? Entropy serves as a universal indicator of disorder and complexity across diverse systems, making it particularly valuable in analyzing complex financial environments such as cryptocurrency markets. Zanin and colleagues' comprehensive review demonstrates permutation entropy's usefulness in biomedical and econophysics research, highlighting its capability to detect subtle patterns and transitions in complex systems, including financial markets. Goyakub and Krejcin illustrate permutation entropy as a versatile measure of disorder and complexity, effectively identifying instability across various domains and scales, including financial systems. Permutation entropy calculation begins by selecting an embedding dimension and delay, constructing vectors from the time series, and identifying their ordinal patterns. By analyzing these ordinal patterns, we measure complexity and identify structural shifts, enabling the detection of market instability. For an embedding dimension of 3, permutation entropy identifies 6 possible ordinal patterns. Each pattern reflects a specific ordering of consecutive data points within the vector. Calculating the frequencies of these ordinal patterns throughout the time series yields the probabilities essential for entropy estimation. The frequency distribution of these patterns helps capture structural changes and emergent instability within market dynamics. The calculation of permutation entropy involves determining the probabilities of each ordinal pattern and subsequently applying the entropy formula. High permutation entropy values indicate greater randomness and complexity, whereas lower values suggest increased order and predictability. This property allows permutation entropy to detect changes in market behavior, providing critical early warning of potential instability. This diagram illustrates the permutation entropy calculation process, where vectors derived from the time series are categorized into ordinal patterns. By generating a frequency distribution of these patterns, we can quantify complexity and monitor changes in market dynamics over time. In addition to classical permutation entropy, we explored three enhanced variants: weighted permutation entropy, amplitude-aware permutation entropy, and uniform quantization-based permutation entropy. Weighted permutation entropy actually assigns weights based on variance or energy, allowing detection of significant amplitude driving market events. Amplitude-aware permutation entropy further incorporates detailed amplitude information, enhancing sensitivity to nuanced market shifts and structural changes, thus providing clearer early warnings. Uniform quantization-based permutation entropy uh, gives us the possibility to handle equal value observations, filtering out short-term noise and highlighting longer-term structural changes, providing stable and robust market complexity indicator. Each variant adds crucial analytical depth, enabling improved detection and prediction of the cryptocurrency market instabilities. To analyze permutation entropy effectively, we employed a sliding window algorithm, calculating entropy within a window that sequentially moves through the Bitcoin price data series. Selecting an appropriate window size is crucial for balancing temporal resolution and analytical accuracy. In our Bitcoin crash study, a 50-day window was optimal, offering detailed insights into rapidly evolving market dynamics. Different input series types, such as standardized returns, were examined to identify the most informative representation for entropy analysis. Our research indicated that standardized returns yield the most reliable and insightful indicators of market instability. So here we present the application of classical permutation entropy and amplitude-aware permutation entropy to the Bitcoin market crash. Both metrics effectively captured market complexity shifts. However, amplitude-aware permutation entropy, integrating amplitude information, provided clearer and more pronounced signals of impending market instability, confirming its superior capability as an early warning indicator. This slide shows results for weighted permutation entropy and uniform quantization-based permutation entropy applied to the Bitcoin crash. Weighted permutation entropy demonstrated strong sensitivity to significant volatility events, rapidly capturing instability, whereas uniform quantization-based permutation entropy offered stable indicators emphasizing sustained structural market shifts, demonstrating robustness to short-term noise. These entropy variants complement each other by providing immediate and long-term market instability insights. In conclusion, our research highlights the substantial potential of permutation entropy metrics, particularly amplitude-enhanced variants like amplitude-aware permutation entropy, weighted permutation entropy, and uniform quantization-based permutation entropy for detecting cryptocurrency market crashes. Classical permutation entropy remains a reliable indicator, but advanced metrics significantly enrich market complexity analysis. Future research will explore these metrics across other cryptocurrencies, integrate entropy analysis with machine learning methods, and develop real-time forecasting systems for improved predictive accuracy and market monitoring. So, if you have questions or wish to discuss our research further, please feel free to contact us. And now, thank you very much for your attention.